let this be 4 meter. The uniform electric field, let it be 10 volt per meter. Now, already you know equipotential points. Can you remember something we have discussed, the equipotential idea? So what are the equipotential surface for uniform field? It should be perpendicular. This is the equipotential line. So what about 192? The potential at 192 will be same. Can we calculate the potential difference between 2 and 3? The field is uniform. According to this formula, E equal to minus delta V by delta X. If the field is uniform, the formula will become very simple. E into delta X. And so what we should write here, no? I'll come with a basic definition. From there, let me start. What is our definition? Our definition is dV is equal to minus of E bar dot dr bar. Now let me find out the potential difference between point 2 and 3. V2, okay, this will become 2 and 3. So this will be V2 minus V3 is equal to minus of. Now what is the angle between E bar and dr? It is 0. Look at the E bar and dr, both are in the same direction. So this will become, and E is constant. So everything will come outside. Okay, agree this. So this will be V2 minus V3 equal to minus of E into. Now what is a dr? Dr will become like a R3, R2 minus R3. So further you can write it as V2 minus V3 as E into R3 minus R2. What is R3 minus R2? So if this you call B, this distance you call A. Let me take this one. So R3 minus R2, shall we write D? And this is the potential difference between point 2 and 3. So if you want to find out the potential difference between 2 points, and if the uniform electric field is there, what is the formula? Just multiply the electric field strength into distance between 2 points. And how the electric field be always directed from higher to lower potential. We know already this one. I think this will be much easier, no? So how much delta or V2 minus V3 is? Electric field strength is how much? 10. And what is the distance? 4. So how much it will be? 40 volt. What is the potential at 192? Will be equal. We can't tell absolute potential. Potential at 192 will be equal. Now I want potential difference between 1 and 3 also. Since V1 equal to V2, so what is the potential at 1 and 3? Potential at 1 and 3, potential difference between 1 and 3 again should be equal to V2 3 only. Any reason? Because potential at 1 is equal to 2. So what you calculate the potential difference between 2 and 3 should also be equal to 1 and 3. Any reason for that? Because it's a conservative field, no? And moreover, potential at 1 is equal to potential at 2. So V1 minus V3 should be equal to V2 minus V3. No, sir, I didn't agree. You do one thing, use same method. Solve it, you'll get the same answer. So here, what potential difference you get between 2 and 3, the same potential difference will be there between 1 and 3. Able to understand? Why 1 and 2 should be equal? Because 1 and 2 lie on equipotential. So what are equipotentials? For a uniform electric field, how the equipotential lines will be for this one? The equipotential lines so we'll agree this. So if this is point 1, A, B, C, D. So all these points are at same potential. Means 1 and 2 will be at same potential. V1 equal to V2 equal to VA. So let me take point 4. Potential at 3 equal to 4 equal to VB. So what are this red color dotted line? equipotential surfaces. How the equipotential surfaces should be, the E bar should be always directed normal to the equipotential surface. I think this we have concluded previous class. Once again, I'm reminding you here. Able to understand now? This is so what you calculate now. So potential difference. Okay, let's do one thing. Let's analyze this problem. Potential difference V23 is equal to V24 S. Similarly, it is also equal to V14. It is also equal to V13. Distance ma just distance R3 minus R2. You calculate somewhere here R3 and this is R2. R3 minus R2 should be equal to D, no? You take somewhere reference point here. Okay, like this, what happened? We can conclude regarding equipotential. So now in this particular field, either you calculate potential difference between 2, 3,